Information Corner Science.
Welcome to Information Corner. In this video, we dive into the fascinating world of invisibility and explore whether it's possible to make objects and even ourselves disappear from sight. We'll break down the science behind various methods and technologies that claims to achieve invisibility, including materials, clocking device, and optical illusion. Invisibility. What is invisibility? Invisibility, the power to vanish from sight or move unseen, has long been a captivating notion in realms of fantasy, science fiction, and myths. It's a concept that finds its way into very fabric of the collective imagination, leaving an intricate mark on popular cultures. From the pages of ancient mythology to the silver screen of the modern cinema, the idea of being invisible has been a source of fantasy and intrigue for generations. Citing examples are in literature. In literature, one of the most famous example of invisibility is from H. G. Wells' classic novel, The Invisible Man, written in 1897. This story tells the tale of a scientist who discovered a way to become invisible, but find that power comes at a great cost. The novel explored the moral and ethical implication of invisibility. Second example is in movies. In cinema, the concept of invisibility has been a recurring theme. Films like The Invisible Man in 1933 and its modern remake in 2020, Hollow Man in 20,000 and Predators in 1987 showcase characters or creatures with invisible power. These movies often use special effects to despite the challenge and consequence of invisibility. Literal classic. Even in literal classes like J.R.R. Tolkien, The Lord of Rings, and one ring provides its wearer with invisibility. Highlight how this power can both be a blessing or a curse. Modern pop culture. Beyond traditional literature and cinema, invisibility continues to prevail. Themes of superpower frequently featured in comic books, video game, television, adding to its end. You have learned the history and culture of invisibility. Now let's understand some principle of invisibility. Let first recall what invisibility is in short, easy words. Invisibility is ability of an object to not be seen. This means the any object which has the ability of invisibility is called invisible. Invisible literal meaning is not to be visible. Invisibility is studied by physics. Now let us understand three scientific processes that can help achieve invisibility. Refraction of light. Definition. Refraction of light is bending of light as it passes from one medium, such as air. Mediums are elements or places where the light passes through, like air, water, glass, and other medium too. Let's continue. Into another medium with an optical density such as water or glass with more density means it the density helps the light to bend. This means when you see an object in air and in and when you see that object in water, the position is not correct as the density makes the light bend, so the object is little bit bent. Now, how it helps for invisibility? Invisibility can be achieved by using metrical with specific refraction properties. Like we use an object which has same density, then it will form a straight line. When light passes from the surrounding environment in such a material, it can bend or refract in a way that it makes it appear as if it continues in a straight line. This means that it continues in a straight lines. It is an illusion, not literally. This gives you the effects of invisibility. Explain. Examples are invisibility cloth. Often use this type of process to refract the light. This makes the object around them invisible from certain angles. The diagram on the right side is a very good example of refraction. As the light in the air is going in the water and the light in the air travels in a straight line, so we can say that the light is scarcely above the pencil and it goes, but as it goes down it's bent and you can see the pencil in another place. It is an illusion. The pencil is literally there, but why do we see there? It is because the light band in this. It makes that pencil invisible and you can see it from another angle. This is how refraction helps in visibility. You can only see the object from another angle. In this example, you can clearly see from the first angle. From as you light is travel in a straight line, it should go here, but it doesn't. That's why refraction helps in visibility, and it's a principle of invisibility. The second scientific process is diffraction. Diffraction definition is the bending of light or spread of light waves as they encounter an obstacle or apple. It occurs when light waves encounter an edge and change direction. This could happen naturally, as they are example in nature. How it helps in visibility is not by making it truly invisible. Diffraction can be used to scatter light in controlled manner. This means you can prevent light from hitting an object, making it less visible, but it is still some kind of visible. By manipulating this diffraction pattern around an object, it's possible to make it smaller or less noticeable than it actually is. Example: some camouflage techniques in nature and military applications use diffraction to distribute the appearance of an object. Additionally, certain material, metamaterial, which we explain further, and cloaking device use diffraction to obstacle the presence of an object. These are usually used in as you can see in the diagram that the light goes straight on the bigger part, but on the smaller part it break into smaller parts, going less. And in the third side, it also break. This happens as diffraction affects the edges. Third and last process is bending of light, a mixture of diffusion, refraction, and refraction. Definition: the bending of light occurs when light waves change direction as they pass through different media, like mediums, the short form medium, media, or when they encounter variation in refraction index of a medium, like the example of density, when the light goes from the air and bends in water because of density. How it works for invisibility: be carefully controlled by the path of light rays around an object. It's possible to make the object appear invisible or blend in its surroundings. Like I said, it is the combination of diffraction and fraction. So it can also camouflage in its surroundings, seeming it more smaller or more invisible. These bands of light effectively diverge the light rays away from object, rendering it unseen. The example on the sun and earth shows a good example of bending of light, and the light that bends because of the sun it shifts in in an angle of 175 degrees. The example of invisibility clocks use metronomium, which are used gendered in refracting, allowing the light to be shown smaller and around a stone. It's important to note that achieving full invisibility is as often despite in science fiction is still a significant challenge due to particular limitations such as wavelength of light and energy required. However, researchers continue to make the process in development technology and materials that will make this dream possible in the near future. These principles at the core are the main cause of invisibility related to scientific experiment and innovation. Like I said in this video, we will also explain some more things. This is a full video on the concept of invisibility. What will happen? Metamaterials manipulating light for invisibility. Metamaterials, like I said, are used for refraction and diffraction. So these are materials that are not found on Earth that have unique properties. These are designed to make art and natural process specialized structure that enables to control the behavior of electromagnetic waves, including visible light, like using them for refraction, diffraction, and bending of light. The three processes of the invisibility curve. Here, how they can be manipulating light and achieve invisibility. Negative refraction. Metamaterials can have a negative refraction index, which allow them to bend light in unconventional ways, like bending in shapes or different sizes. This property is crucial for creating invisibility cloth because it enables light to flow around an object. Like you, when light hits an object before it, you can make it a circle and go away, and making it appear invisible from certain angle. So this will be invisible from the front and the left, but from the right and back it will be visible, not achieving full invisibility. Let's move on. Cloaking is structure. Cloaking structure and metamaterials are often used to create cloaking structure that guides manipulating of light. They can guide manipulating of light by using them in different shapes. These structures are designed to interact with light such a way that they can affect height or an object placed within them. These can hide objects placed in them. These are cloth as they can hide it. And scientists have these cloth and they are researching on them. But the major flaws I will tell you later are in them. So we are still processing them. Or we have some kind of invisibility. The most known is valid example is invisibility clock, which has been a subject of research and experiment. Frequent control. Frequency control is a major path to control light. The metamaterials are designed to frequently control light. So, if they do not have these properties, they will control light in one direction. But light keeps going and going, and they will be some after some time they will be visible, allowing for manipulating of light in ways that can make object invisible with certain precision from electromagnetic spectrum. This technology has potential application beyond visibility of light, including in microwaves and infrared regions. Next, we will talk about limitation of light or another thing is clocking device. Like I said, invisibility can only be achieved when light do not hit an object. It makes it invisible. When light is not present in an area, it goes dark. And it is called shadows and appear and everything goes black. But invisibility is another thing. When you just bounce or curve an object from which the light do not touch, but the light is still present. This makes an object invisible. Clocking devices are used to do this. Now let's understand more about clocking device, real life application and potential uses. While full flash invisibility clock as seen in science fiction are not yet a reality, we can only make some from some angles. There have been significant advancement in the development of clocking device that have made particular application like military application. Clocking device have the potential to revolutionize military technology. They can be used to make military vehicles, aircraft, and even soldiers less visible to the enemy. This can enhance stealth capability, improving survivability, and provide a strategic advantage in combat situations. Medical imagination. In the medical field, clocking technology can be used to create devices that make certain area of body transparent to specify wave or length of light. This could admit in non-invasive medical imaging techniques, such as improving accuracy of ultrasound or Endoscopic procedures. Material clotting. Clotting technology can be used to create clotting for materials and structure, making them less visible to radar, infrared sensors, or other declaration matter. This has application in aerospace, where reducing the radar cross section of aircraft can enhance their stability. Camouflaging. Beyond military uses, cloaking technology can be used for camouflaging purposes. This can include making buildings less visible, improving wild observation or design. A good example of cloaking devices is in the diagram. You can see a man disappearing in half in the clocking device. He cannot be seen clearly, but the wall can be seen. This how light is bouncing off, but the light is still present, making the man invisible. The light is only bouncing off the man, but you can see the man from a different angle. This is the technology for we have today, and we will advance it from more in the future. Challenge and limitation through invisibility. Now you must ask a question. If we have a technology like this that you have seen the diagram in the previous video, previous slide, why cannot we have true invisibility? Well, there are limitations to achieve true invisibility. The first limitation is wavelength. Achieving true invisibility is related to the wavelength of light. Invisibility clocks and devices are typically designed to work with a specific wavelength of broad spectrum invisibility, meaning that if you put more or less light wavelength, you will be visible. Especially in the visibility spectrum, is extremely challenged due to the wide range of wavelength involved, because there are a lot of wavelengths that can be possible. Now, the second factor is energy consumptions. Many technologies require significant amount of energy to be consumed, often in forms of ex- extract material or complex equipment. This makes them impractical for everyday use and raise concerns about their environment impact. Now, next is practically the design and construction of invisibility cloth and device can be highly complex and expensive. This often involves intricate arguments of mathematical or specialized structures. This complexity can limit their practically for widespread application. Next is viewing angle and geometry. This is a very important thing, as you need to bounce light into a different angle and different shape for true invisibility. Invisibility technology often work well when viewed from specific angles, but may fail to provide complex invisibility when observed from other perspectives. Achieving true 360 degrees invisibility remains a significant challenge. Size limitation. Invisibility clocks are typically designed for a specific object or scale. Scaling up or down the technology for different application can be difficult, meaning to make a tank disappear is much harder to make from making a man disappear. Next is active versus passive invisibility. Many purpose invisibility technology record active control and external source of function, meaning they need a constant revolve on the edge. Passive invisibility, where an object remains invisible without ongoing energy input, is more desirable but harder to achieve. This can lead to major arguments. The last thing is matter constraint. The matter used in metro materials and clocking device must have specific optical properties, which can be difficult to engineer and manufacture. Some materials have invisibility may have limitation in terms of duration, flexibility, and toxicity. Now let's understand some optical illusion and democratic invisibility. Some optical illusion that can help us make to illustrate the concept of invisibility, how optical illusion can trick our brain. You can include a segment in your video showcasing intricate optical illusion and experiment. Here are some ideas. Invisible mannequin. Invisible mannequin show an optical illusion involving a mannequin covered with a fabric that featured a pattern resembling the background. When you view it from a certain angle, the mannequin appeared to blend in the surrounding, creating the illusion of invisibility. Migrate effect. Discussing the migrate effects which occurs due to the blending of light in the atmosphere. Camouflaging patterns. Display example of animals or military camouflage patterns and how these patterns exploit the vision and perspective to make objects blend into the environment. Transparent trick. Use transparent material or object from which they can be viewed from a different angle and be invisible. And lastly, anomeric. Present anomeric illusion that appears difficulties from one perspective, but they are not real. Like I have used two of these. In the first segment, I used the books disappear and they are used for invisibility. And then in the second one, I have also explained the invisibility rule and the invisible man of the diagram of the invisible man. He is blending in his surroundings. These how optical illusion works in videos and you can make them in real life too. But these equipments are very expensive and are used mainly for scientific use. Like in this slide, I've used the first method, making a mannequin which is blend in with with the background. Can you find the mannequin that is blend in the background in 5 seconds? Lastly, I want to thank you for watching this video and please like and subscribe this video if you understand the full concept of invisibility. These are all the things that you need at in this world for invisibility. Invisibility is a very fascinating concept which will be further explored in much later videos. Thank you.